Some properties and rules of exponents. We're going to be going a little fast on these. So this first one, when you multiply your bases, you add your exponents. So when we add our exponents over here, we're going to get x to the 7 plus 5, which is 12. To have an exponent raised to a power, you want to multiply the exponents. So in our case, it's going to be h to the 36th power. When you have a product raised to an exponent, that exponent actually is going to go to both factors or all of the factors in there. So this quantity ab to the 5th is just a to the 5th, b to the 5th. And these are all just ways to simplify exponents. When you have a quotient raised to the exponent, it's the same idea as above. That exponent goes to both numerator and denominator. So this will be a to the 8th over b to the 8th. Next up is an easy one to remember. Anything to the 0 power is 1. So 7 to the 0 power is 1. When you divide bases, we subtract exponents. So for our example, this will be d to the 7th, because 10 minus 3 is 7. The last two go together. If you've got a negative exponent, it's moving to the denominator and then becomes positive. So in our case, this will be 1 over c to the 12th. And then this follows the same idea. If you've got a negative exponent in the denominator, it moves to the numerator and then becomes positive again. So notice we have g to the negative 3rd in our denominator. It gets moved to the numerator, which would just be over 1, which we don't have to write. So now let's simplify. These coefficients out front, we multiply like usual. They're numbers, they're not bases. So negative 8 times negative a half is positive 4. Half of 8 is 4. Our a's, we're multiplying them, so we want to add our exponents. So we'll have a to the 6th. This b doesn't have anybody to multiply by, so it's just times b. This next one, notice we have exponent raised to an exponent, so we multiply those, so it'll be b to the 12th. And then here, same idea, exponent raised to an exponent will multiply, that is b to the 14th. And now these two bases are getting multiplied, so we'll have b to the 12 plus 14, which is 26. Alright, now remember we've got a quotient raised to an exponent. The exponent goes to both of them. So this, we can think of it as a to the 5th cubed over b to the 7th cubed. And now we've got an exponent raised to an exponent. So we'll multiply the exponents. So a to the 15th over b to the 21st. And if you can skip this middle step here and go straight from here to here and multiply, that's fine. This middle step just helps clarify what exactly is going on. So this next one, once again, our bases are getting multiplied, so we want to add our exponents. Negative 7 plus 3 is negative 4. But now we've got a negative exponent, which means it'll be a to the positive 4 in our denominator. We've got an exponent raised to an exponent, so we'll multiply. So negative 5 times negative 3 is 15, so we'll have a to the 15th. So we've got exponent to an exponent, so we'll have a to the positive 6. In our denominator, we'll have a to the negative 6. And from here, there's really two ways you can do it. Since you see that this is a negative exponent down here, we can move it. So this a to the 6 will stay here. This one will come up and be a to the 6 because it's moved, so it becomes positive exponent. And now we add across our exponents and a to the 12th. Or from here, what we could have done was when we divide, we want to subtract our exponents. So we'd have a to the 6th minus a negative 6. And remember, when you have minus and negative, we add, which gets us to a to the 12th. So either way works, and it doesn't matter. You want to simplify what you can inside parentheses first. Remember, in order of operations, do your grouping symbols. So in our parentheses, notice this a with a negative exponent, so it's going to move down, and our square is going to be positive. And notice our b's here, we want to subtract, so we'll actually have b to the 5 minus 8, which is b to the negative third. But we don't want this to be a negative exponent, so it'll be moved then to the denominator as well, which means we just have 1 left in our numerator. And then we still have this power of negative 3. Another way of thinking about this part right here is you have 8 b's in the denominator, 5 b's in your numerator. So 5 of them are going to cancel out with each other, and you'll have 3 left in your denominator because your denominator had more to begin with. Now, I'm going to just separate this so it's not confusing. Let's take care of this negative. And remember, a negative flips your fraction. So we'll have a squared b cubed in our numerator over 1, which doesn't do anything, now to the positive 3 because we took care of that negative. And now this is like ones we've done before. You've got exponents being raised to an exponent, so we multiply. So a to the 6th, b to the 9th. This one looks confusing and complicated. Just take it piece by piece. So let's go ahead and get started. We're not even going to worry about this negative 2 out as exponent. Let's first worry about this part. How can we simplify this? What can we take out of both? We can divide a 3 from both, and when we divide a 3, we're left with 4 in the denominator and 9 in our numerator. Now let's look at our a's. We have a cubed in the numerator and a to the 9th in the denominator. Notice 3 will cancel out, we're left with 6 in our denominator. Or if you subtract, you'd have a to the negative 6 and then move it. That's fine too. Looking at our b's, there's different ways you can do this. If you want to get rid of your negatives first, we can change it so that we have b to the 8th over b to the 5th, so that those negatives aren't there anymore. That's fine. These c's, notice we have c to the 7th over c to the 7th, and they'll just cancel each other out. Now, let's still worry about these b's. And remember, when you divide, you can subtract your exponents. So when we subtract our exponents, we'll have b cubed, and since that will be in your numerator. And then we still have all of this to the negative 2nd. Look at already how much easier this looks and how much more simple. Alright, so once again, this negative means we're going to flip our fraction. So we'll have 4a to the 6th over 9b cubed. Now it's just to the positive 2 because we took care of our negative. And now everything just gets squared. So we'll have 16a to the 12th over 81b to the 6th. So it's not too bad if we just take it piece by piece. Our t's, we can simplify. Remember, we subtract our exponents, so we'll have 2t to the n minus 3 all over 3. Now all of this is to the 5th power. So now everything is to the 5th power. 2 to the 5th power is 32. And let's take care of this 3 to the 5th power as well. That gives us 243. But now when we're going to have this t to the n minus 3, when we have an exponent raised to an exponent, we want to multiply our exponents. So we'll have that. But let's make this look nicer. So we'll have our 32 240 over 243 t to the 5n minus 15.